Hey guys, I'm here today to show you guys how to do a Punnett square. So the premise of a Punnett square is to kind of guess what the offspring of a mate is going to look like, a mate between two parents. Now you can tell the alleles of the parents by their ancestry. So if someone has a history of color blindness in their family, they might be carriers for color blindness. If someone does not show any records in the family of color blindness, then they're dominant in both with both alleles. So this would be a mate with dominant both alleles. So they would have no chance in the family of getting a colorblind kid. Now, for this parent, they are a carrier because they have a dominant and a recessive allele. So now we pair them together. We pair this with this, this with this, this with this, in a nice box pattern, and we see that this child is completely dominant. We call this one homozygous because they're both dominant. Another homozygous child, and these two are heterozygous, which means that they have a capital and a lowercase letter. Now, so with this Punnett square, for color blindness, we can tell that 100% are not going to be colorblind because they all have the dominant allele, and the dominant allele trumps every recessive allele if it's in the pattern of 2. But 50% of them are going to be carriers. So with this 50%, if they mate with another carrier, there is a 25% chance that their offspring will be colorblind. Now, if you go here, where we have two heterozygous mates, we have these two coming together as a homozygous dominant, so they are not going to be colorblind. But these two, we have two carriers, so 50% of them are going to be carriers. And now, as we get down to here, we see that there's two lowercase letters. This means that there is no dominant allele in this offspring's mix, so they will be colorblind. So I did the math here. 25% of them, 25% of them will be colorblind, which is the recessive one, and the homozygous recessive. 75% will not be colorblind, which is all these three, because they have this uppercase letter, and 50% are going to be carriers, which are these two. Now, this is a big difference between a dihybrid cross. With a dihybrid cross, you're looking at something like curly hair and brown eyes. Two different things. So if we have a parent that is dominant for curly hair with a recessive allele, so they're heterozygous for curly hair, and they do not have brown eyes, they have a different color eyes. And then for this parent, they have curly hair and brown eyes because they have the dominant alleles. So with a dihybrid cross, we can see the big picture and the big spectrum. So if these two mates were to have offspring, I underlined the ones that would be both curly-haired and brown-eyed. So someone like this would have no curly hair, so they would have straight hair because the curly hair is not dominant. They're both recessive alleles. And they would have brown eyes because this is a dominant allele. And somebody like this is all recessive. So they would have straight hair because they have no capital S for curly hair. And they would have a different color eyes because they have, they're recessive in eye color too. So basically Punnett squares tell us, help us guess what the offspring are going to look like between two mates. Thank you. Have a good day.